So utilizing these limits, working with these limits, should get comfortable with doing with that. We'll see these limits show up again, the sine of theta over theta and the 1 minus cosine over theta. We'll see those limits show up again as we move into chapter 3. But make sure that you're familiar and comfortable with moving along with these types of limits. Okay? All right. Very good. That's the end of 2.4. It moves us on into 2.5. All right. So chapter 2.5 is on a topic that's important to us because it needs to be. 2.5 is on what's called continuity. And I'm sure all of you have heard about continuous functions before. You know sort of what, you have this understanding of what a continuous function is. You can think of continuous functions in a very rudimentary way as being sort of a function whose graph you can draw without picking up a pencil. Okay? That's sort of a rudimentary definition of what continuity is. But we need something a little bit more precise in order to do our calculus work. So let's take a look at the following graph. Alright, so here we have a function y equals f of x. I'm not going to write down any sort of formula for it because I'm not so much interested in the formula. What I'm really interested in is the picture that we get out of this particular graph. Okay. Now, using your notion of what you think of when people say continuity, where is this function continuous? And where is it discontinuous? Take a look at it for a moment. Try to figure out sort of the answers to these two questions here based on your own intuition of what continuity means. Discontinuous obviously being the absence of continuousness. So I find typically it's better to go with the second of the two questions. Where, based on your intuition, is this function not continuous or discontinuous? Where is this function discontinuous? X equals 1. Okay, so we're going to say x equals 1. Where else? 2. Say x equals 2. Where else? 4. All right, so let's take a look at what happens to our graph at each of these 3 points here. Okay. So we say that you're claiming that this function is not continuous at x equals 1. Why? Okay.
There's no value at 1.
What's that?
There's no value at 1.
There is a value at 1. It's actually up here. Okay. There is our value at x equals 1. But what else happens at x equals 1?
There's a break.
There's a break in our graph, right? There's a break in our graph here where the function is getting closer and closer to 1, or closer and closer to 0 at x equals 1, and then magically it jumps up here and starts a new branch. Okay? So it's discontinuous at x equals 1 because it jumps from one part to another. We'll come up with some more accurate terminology here, but that's sort of what happens